Science, magnetic effects of current. In 1820, Hans Christian Ørsted, a Danish chemist and physicist, discovered that electric currents create magnetic fields. Magnets aren't the only source of magnetism. A circuit wire has a magnetic field around it whenever a current is passed through. The orientation of the iron filings in the card and the plotting compass deflection shows that there is a magnetic field around the wire. The field can be imagined as a series of concentric circles at right angles and is perpendicular to the wire, which is at the center of the magnetic field as shown in the figure. Magnetic field lines are imaginary lines that show the direction and strength of a magnetic field. We know there is a magnetic field around circuit carrying wire. When a small current, say 2 ampere, is passed through the wire, a weak magnetic field is produced. If we increase the current, say, to 20 ampere, the field is strong enough to be detected by the iron filings on the cardboard. The pattern formed by the iron filings shows field lines like circles centered about the wire. The direction of field at different points can be found using a plotting compass. If the direction of current is reversed, the field direction is also reversed, but the field pattern is otherwise unchanged. Properties of field line is that the direction is from North Pole to South Pole outside the magnet. They never intersect, means each point has only one direction. The density of field lines indicates strength. The difference between electric field likes and magnetic field lines are: the electric field lines start on plus charge and ends on negative charge. Magnetic field lines have no starting or ending points and they are continuous closed curves, forms closed loops since isolated magnetic poles or monopoles are not found in nature. There is a force on current carrying conductor. That is experienced when you put current carrying wire on a magnetic field. This is the principle behind electric motors. Fleming's left-hand rule. This tells you the direction of force on a current carrying conductor in a magnetic field. It says, first finger or index finger is in the direction of magnetic field, which is from north to south. Second finger or middle finger is in the direction of current, which is from positive to negative. Thumb is in the direction of force or motion. A solenoid is a long coil of wire with many turns. When current flows through it, it produces a very uniform magnetic field inside and a weak field outside. The magnetic field lines inside is from south to north and outside it is from north to south. In real life, solenoids are used as electromagnets in cranes, doorbells, etc. Major forms of current are direct current and alternating current. In direct current, current flows in one direction only. The voltage time graph shows the constant magnitude and direction of DC current. DC current is used in mobile phone battery, laptop battery, chargers, car battery, electronic chips, etc. In alternating current, current reverses direction periodically. The voltage time graph shows the magnitude and the sinusoidal direction change. Alternating current, AC, is primarily used for powering homes and buildings, running industrial machinery, and long-distance transmission of electricity from power plants to substations. Frequency of AC. Frequency is the number of cycles per second. Time period is the time taken to complete one complete cycle. The formula for frequency is 1 divided by time period. Here in the diagram shown, time period is 3 seconds. Let's do a problem. The AC supply in India completes 50 cycles in 1 second. Find frequency and time period. Frequency is already given as 50 cycles per second. So it is 50 Hz. Time period is 1 divided by frequency, which calculates to 20 milliseconds. Advantages of AC over DC. With AC, transformers can easily step up means increase, or step down means decrease voltage. With AC, there is reduced power loss in transmission. AC motors are simple, durable, and with low maintenance cost. Domestic electric circuits. The standard home electrical system. In India and most countries, the supply voltage is in the range of 220 to 240 volts AC. Frequency is 50 Hz. Single phase for homes and 3-phase for industries. There are 3 wires in home circuits, which includes a phase, neutral, and earth wire. Phase wire brings current from the supply. Neutral wire completes the circuit, returns current to the supply. Earth wire is for safety only and normally carries no current. By understanding the house wiring system, you can do proper planning and installation if you're building a new home or updating an older one. Video by Anand Mohandas.